Hey guys, so today I'm gonna show you a satisfying proof on the product rule. Somewhat satisfying, for me at least. I feel like people should really understand and grasp on how the formula derived, so that you could really understand and remember. You don't really have to force yourself, and then you can just remember how to do the product rule instead of, oh shit, I forgot. So let's dive right in.
It's a must, okay? We should memorize, we should remember the first principle. So we, we know that for any derivative of a function, f of x, forgive my handwriting, I'm somewhat disabled. So any derivative of a function is taking the limit of h approaches 0. The h is the difference, the gap, okay? And the first principle is the fundamentals of calculus or differentiation or integrals. You should, by now, if you don't know, just refer back. There's a lot of good tutorials out there. So taking the limit of h approaches 0 of x plus h, fx plus minus the f of x right here. So the thing on top right here is basically the difference of y value right here divided by h. So this is our formal definition of our derivative, finding the derivatives of the function right here. So this is going to be very useful in our future steps right here, which we're going to do for our proof. So it's better, it's best if we could remember, just understand the formula first before we proceed with our proof. Okay, so let's go back to our proof. So we have so we have to find our derivatives of a composite. So f of x multiplied by gx. So how do we find that? So let's just try to put this thing into our original formula we have right here. So we're gonna get the limit of h approaches 0, which is the same, and the function of x plus h, which is, for our case, our function is fx multiplied by gx. So what's x plus h? Will be just x plus h inside, and our function remains the same. We just take back the same function we have right here, minus f of x. So for our function is fx multiplied by gx. So fx multiplied by gx. If, by the way, if you don't know why this thing looks like this or this, how to evaluate, you should go back high school. You shouldn't be here. So we have substituted in the value that we have right here to find our derivatives. But here's our trouble. What's the trouble? Well, how do we evaluate this? There's no further things we could do right here if we continue to look at this piece of expression right here that way. It's going to lead us nothing. So what I'm going to do here is a little bit of algebraic manipulation. I didn't make this trick out. It's not me. I'm not going to take the credit. I'm not that genius. Some genius out there maybe spend days without touching grass and figured out this way. So congrats to him. Not to me, because I did not figure this out, but I bet most of you guys don't even know. So I'm gonna show it to you in a more humanable explanation. So what I'm gonna do here is try my best, okay, to get the form of something like this we have right here, the formal definition. So the trick right here is gonna get very tricky. So put your eyes wide open, or else you'll miss out every detail. So what I'm gonna do here, I'm gonna use, so the same thing, I'm gonna use back the same color. So we're gonna use, so the limit remains, and I'm gonna draw a very long line. Why? You'll find out. So divided by h as usual, and then the same thing remains. I'm gonna write this back, x plus h, so, and then something, I'm gonna leave something right here, okay, and then you see why later, minus f of x multiplied by gx. Okay, so I'm leaving this blank right here is because I want to put something in so that I could maybe factorize out, or factorize something out. That's exactly what I'm going to do. I'm just trying to make this thing more interesting. So I'm going to put something in here, and then I'm going to try factorize this out so that I could get something in the form like this, somewhat in the form like this. So what I'm going to do here, I'm going to put it in this red color. So I'm going to minus
F x plus h multiplied by gx, and then because I'm putting something that doesn't exist in this expression right here, I need to add it back so that it cancel out each other. So adding back the same thing, x plus h multiplied by g of x. So at this point you can see, now I'm putting some common factors right here so that I can factor out, and you see why. So I'm gonna so we have two common we have in fact two common factors we could factor out. What I'm gonna do here is I'm gonna factor fx plus h with this thing right here, and then I'm gonna factor my g of x right here out of the expression as well.
And you see why very soon. So, same thing remains, the limit h approaches 0. And then I factor out my fx plus h. fx plus h multiplied. I'm gonna put this in other color. So, I factor out fx plus h. It gives us g of x plus h minus g of x minus, oh my god, I hate this, keep changing colors, but for the sake of understanding, you should appreciate it. So, so I factor out g of x for this one, so which leaves us g of x multiplied. So, I factor out g of x right here, which leaves us with fx plus h minus f of x. I'm dealing with this part, okay? I factor out my g of x right here, so to make this thing clear. So for this front part, I'm playing around with this part. I factor out my my fx plus h and this fx plus h right here. I factor this out of this expression. Okay, and then divided by that long ass line down here, divided by h. Okay, excuse my bad maneuvers on this tablet. Okay, so now you can see something that is very similar to our first principle right here, to our formula. So you can see we have gx plus h minus g of x, and then we have fx plus h minus f of x. So this is something that is very close to what we have right here on top of a formula right here. So I think for those who are very good at algebra, I think they're gonna know what's gonna happen next. Sorry, this is supposed to be plus, not minus. So what I'm gonna do here, this is also I believe this is the most important part of the proof right here. So I'm gonna separate these fractions into two parts. So since they only share the same denominator, so it's okay that I just split this up. Let's say I have a q plus a divided by some constant k. I can just say q plus divided by k plus a divided by k. So I can just split this two up. What I'm going to do is exactly what I'm going to do. Since I have a plus right here, I'm going to split this into two fractions. So limit of h plus 0 plus the limit of h plus 0. The limit rule implies that I can split this 2 and I can split this 2 into two limits if they share same denominator. So I take back the same thing right here. We have f x plus h multiplied x plus h minus g of x divided by h and then plus g of x multiplied with this expression x plus h minus f of x divided by what, class? H. Good job. Okay, so now we have this expression right here, a huge ass expression. Okay, so I'm gonna copy this down for the sake of space, of course. Then I'm gonna put a little comparison between the first principle we have right here, so that you dumbass can realize what is happening. There we go. Copy and paste, yada yada yada. Pop pop pop. Screw screw. Okay. Oops. I think this is a little bit too trash. I'm gonna paste again. Make this smaller, somewhat smaller. Okay. So I want you guys to do a little comparison on what you can see.
So what can you see? What can we take? What's the take we can do? I think you guys see it. Okay, so we have this part right here. This part right here. Isn't it just exactly looks like the one we have right here? We have gx plus h minus g of x divided by h. And then this formal definition implies that the derivatives of any function is fx plus h minus f, which is exactly the derivative of this function, this piece of function right here. I'm gonna make this, I'm gonna clean this up a little bit, okay? Because if you guys didn't see it, it's okay. I'm gonna try to make this as clear as possible. So I'm gonna continue to make this looks cleaner than it should be. So this thing is not relevant, okay? It's relevant, but what we are focusing here is this piece right here that we want. So I'm gonna, since this is a multiplication of two items right here, using basic fractions manipulations, I can just rewrite this as something like this.
So gx plus h minus g of x divided by h, and then this thing I can just put this right here, multiply fx plus h, and it's exactly the same thing we could get back. Okay, if we multiply this back, god damn it, are you serious? If we multiply this back into this, we would just get back what we have right here. So this expression right here is done, it's well cleaned up. I'm gonna do this the same, plus limit of h approaches 0, g of x. I'm gonna do that, I'm gonna put that behind, but I'm gonna put the expression that I want to focus on in front. Fx plus h minus f of x divided by h, and then multiply by gx, which is non-relevant. Outsiders. Okay.
So now we have something very familiar, isn't it? In it, class. So now we can evaluate our limit, okay? Because what I need you to focus on what we have right here, okay? What we have right here, because this two thing right here is exactly what we have for our formal definition of our derivatives. So let's evaluate this, shall we? So this thing right here, this thing we have right here is basically the g prime of x, because the limit of x plus h blah 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 divided by h is the derivatives of that function. So we just write this back down, g prime of x. I'm gonna write this in different color for the sake of, so I'm gonna get g, so taking the limit, okay, on this piece of thing right here gives us g prime of x. And because fx plus h is also taking the limit as h approaches 0, so we're taking this as well. So as h approaches 0, we'll just get x plus 0, so it just gives us f of x. So g prime of x multiplied by f of x. This piece is done. And then moving on to the next part of the function, plus let's evaluate this part. So taking the limit of h approaches 0 on this piece of function right here is basically fx plus h, which is exactly the same as what we have on our first principle as well. So it will just gives us the f prime of x. This piece of thing right here is gonna give us this, and for this piece thing right here, well, this thing is not relevant because there's no h in it, so we can just put it back, multiplied by g of x. So there we have it, guys and girls and all those. Now I'm not gonna include them. And there we have it. We have the formula for the product rule. So I'm gonna write this down again. So now we have found for any derivatives of a compound function, a product function, we can use this formula right here, g prime of x, f of x, plus f prime of x, g of x. There we have it.